Good afternoon, everyone. It's a real pleasure to be here. And in the next half hour to 40 minutes, I'm going to be talking on the ocean, the future we want. So what I want to do is really kind of lift the surface of the ocean and look underneath the surface, tell you something about the latest science about what's happening to the ocean. The ocean is going under massive change, and Iceland actually sits at the forefront of where some of those changes are occurring. So this presentation is about telling you about some of that science, but it's also a bit of a story also about connections to the ocean. I'm an islander. I look at Iceland as a very large island, and I was born on an island just 8 miles by 6, Jersey and the Channel Islands. So it's a story also about the affinity we have to the ocean and the connections, and you'll have connections to the ocean living here in many different ways, just as I did. I grew up with the ocean for the first 18 years of my life before I had to leave the island. We didn't have universities on Jersey and the Channel Islands, so I then went off to England. And so it's really about the science of what's happening to the ocean, but the changes that we can see. And when I was a small child, and this is me younger than I care to remember, with my parents, about 6 years old, my favourite beach. And Jersey and the Channel Islands has one of the third largest rises and falls of tide in the world. And so when the tide went out in that bay, and it went right out to that tower, when I was young, I'd put on my homemade wetsuit and go snorkeling and look at the marine life. And that's where I saw changes happening to the ocean myself. And I think that's what's really compelled me to look at the ocean, to try and understand the ocean, to try and impart information about the ocean, so you can all make your own decisions about what you see and plan better for the future. And for me, when the tide went out and I'd snorkel, I'd see massive aggregations of spider crabs coming in to breed, and you would duck down with your snorkel and take one for the pot to take home and eat, and another would roll into its place, and the seabed would be covered by them. And now you very rarely see that. We've interrupted the migrations, we've taken them further offshore, so the ocean has changed, and that's my personal link to the ocean, but you may have your own links in your own ways. And so this presentation, whilst it's about the ocean we might want in the future, it's also reflecting on the ocean of the past and how things have changed. And our world has changed considerably in my lifetime. It was in my lifetime that we really viewed the Earth from afar and gained our sense of place. NASA, the Apollo moonshots, the competition to go to the moon gave us our first images, and very iconic ones. This is one taken by Apollo 8, William Anders, in 1968. I'm still in my early childhood, called Earthrise, and that was when the Earth was seen for the first time rising above the surface of another body in the solar system, in this case the moon. And since then, a lot of things have changed. When we reflect on those 40 years, that Earth we saw from afar, blue, finite, hanging in the void of space, has turned into a digital world. You've all been using your phones, I see, just now. So the digital version, Google Earth, downloaded now by between 1 billion and 2 billion people, enables us to bring the ocean to events like this. The Indian Ocean, the world's warmest ocean. The Pacific Ocean, dotted by small island states, which really shows that we are an ocean planet. It's ocean that occupies the most of it. The Atlantic Ocean, with the erratic zip-like fastener of the mid-Atlantic ridge. And then, of relevance to what I'm going to talk about today, places like the Arctic Ocean, compromised by climate change and ocean acidification. So what can we learn from the ocean of the past? What ocean may we get unless we do something? And what ocean do we want for the future? And that brings me, with just a little help from Google, to our meeting today. You can land on the roof. So when we think back over my lifetime, the last, dare I say, sort of 50 or so years, back then it was a time of discovery. What I used to watch on television was the adventures of Captain Cousteau and the Calypso, and it gave a real sense of adventure, and it was a time when we were just inventing diving equipment, aqualungs and the like. And since then, I think we've connected quite a few values to the ocean in our own ways. The way the public view it is a place where they go on holiday. Others may view it as a place where it's got immense values for the things we can take from the ocean. And others may just look at it like this amazing place on the west coast of New Caledonia in the Pacific with honeycomb coral reefs as just an amazing place, amazing, beautiful place. In that time, we've also changed our perspectives with science and knowledge about the wider ocean. We might have known quite a lot about the coast, but the deep ocean, perhaps in many people's minds, was this traditional view of something which is perhaps in some people's minds dark, dangerous, boring and uniform. And science has shown us that it's changed considerably. We now know that it is a very varied environment, the open ocean, from seamounts teeming with life, to cold water coral reefs like you have in your neck of the woods, to canyons and even to reefs made of mass aggregation of sponges. We also have found in that time that it's a place with unique ecosystems we never imagined existed. And it's all comparatively recent that we've discovered this. So it's back in 1975 that Alvin, the US submarine on the Galapagos Ridge, discovered ecosystems not powered by the light from the sun, but powered by ocean chemistry around these smokers, the hydrothermal vents. It was just under a decade later that we then found that there was life connected to methane seeps in the deep ocean, unique ecosystems. And then even more recently that we recognize the significance of things like whale falls, the death of whales reaching the deep ocean and forming unique, albeit very small, habitat areas in their own right. And we know it as a place of ocean spectacles, from humpback whales through to, on the bottom left, mass floating communities of algae in the Atlantic, the Sargasso Sea, a place of myth and legends, the place of the doldrums, of becalming ships, and also places where we have intense gatherings of ocean life. So when you look at the ocean, what do you see? Do you see the beautiful blue planet? This is NASA's most complete, best image of the whole of the world. Or do you see a place of immense values and riches that supports us? I could show a photo here of fish catchers, but I'll show something perhaps less obvious. And again, this was discovered very recently in the mid-80s. So the light blue in that is the most photosynthetically abundant organism on the planet. Until the mid-80s, we thought it was varieties of trees and species of grass that gave us our life-giving oxygen. But it was in around 1986, actually in the Sargasso Sea, they isolated something called Prochlorococcus. It exists in several octillions, and for those not billions or millions, octillions are something like 10 to the 27, an infathomable large number. And so you owe every second breath you take to these microscopic organisms in the ocean, for that's where half the oxygen that we breathe comes from. Or do you look back and do you see an ocean that has been changed considerably by our activities? It would seem unimaginable when I was brought up and I saw the first NASA photos that we could change the blue bit, but we are changing the blue bit. And this is a paper that a chap called Ben Halpern did in 2008, where they brought together information across many impacts to look to see how we'd started to change the blue bit of our planet, the whole ocean. And what he discovered was, amazingly, around 41% of the ocean is heavily affected by our activities. I guess it's because the sea goes in and out and it looks the same and it's still blue the next day that we don't realize the cumulative effects that we're having. And as I'll show later in the presentation, the effects are actually probably more progressive and worse than the direct impacts. And so what we've also learnt to realise is it's the ocean that drives our climate. It's the ocean that provides a fair proportion of the oxygen. It's the ocean that provides food for 1 billion people directly from fisheries. And it's what sets us aside from other places that either have had an ocean millions of years ago, like Mars, or other places that are seen as inhospitable to life. It's absolutely finite as well. And so the issue right now is we need to make decisions about how we look after and care for it, and not perhaps just exploit it. And the problem, ultimately, is us. When I was born, there were only 3 billion people on the planet. There's now over 7 billion people. And we are an incredibly creative species. And whether it's the ocean or whether it's a place like a desert, we have found ways to exploit space, exploit resources, and to feed ourselves. The Saudi desert, a place you wouldn't imagine where we could cultivate things for food. And this could be anywhere, and it shows the relentless pace at which we're exploiting the Earth's resources. We're also very good at shaping it to our own needs and our own ideals. Take Dubai. This just demonstrates again the amazing pace of change. Year 2000, a coastal strip with some development. 2003, 2007, and 2011. And again, it could be anywhere else, but it shows we forget how quickly we're changing things. And a recurrent theme through my presentation is not that we haven't had change before in the Earth's history. It's the scale of change and it's the speed of change that is increasingly worrying the groups of scientists that know about these things. And it's not the obvious things, it's the less obvious things that are now a cause for concern. And in all this time, we've done a pretty poor job at protecting the ocean. We've protected, in total, 2.8% of the ocean. Many of them are too small to even see. The trend is twofold: to increase protection through small areas, but also an increasing trend of countries to compete to get the largest marine protected area in the world. Well, that may help that region, but the reality is we need to be looking across the whole ocean and doing better as a whole. So it's not so much now just about special areas we protect as how we look after the whole ocean. So if we don't change and we don't act on the science, what is the future ocean we may actually just get? Nature will give it to us. Well, when you look at this and you look at human expansion, you look at altered ecosystems, and you remember those ocean basins I just flew you around, there is actually a repeating formula in each of these ocean basins of change. Starts with fishing, pollution, and then as we develop techniques, mechanical habitat destruction, then as we got better at shipping things around the world, introductions, and then multiple stresses. And these act synergistically together. Now, it would be really easy for me to come here today and say, do you know what, I'll talk about fisheries, I'll talk about marine protected areas. But the thing that is really worrying a lot of us is not so much the stuff down the bottom here, but effectively what we call multiple stresses. And this is the sum total of the effects we're having on the ocean. So this goes beyond having perhaps regional or different perspectives over should we exploit, should we protect, what should we do, to the fact that multiple stresses, climate change, oxygen sags in the ocean, and acidification are effectively a rail train coming through that is going to overtake those debates. It's not that those debates aren't important, but it's about the fact that the world around is changing, and we are changing it faster than anything in human history. The cause of this, in part, is what we're doing to the climate effects. So this is a classical graph of the amount of carbon dioxide parts per million volume in the atmosphere over the last 20,000 years. And it started around 180 parts per million. And then pre-industrial revolution, 280. And then when I started these presentations, it was 385. Then I had to add a bit on the graph because it's now 400. And this peak, some have called the Anthropocene, the artificial era that we're creating by the amount of carbon dioxide we're setting out. But I don't think this graph doesn't really bring it home to you till you put your carbon dioxide birthday on this graph. And not many people do this. So if you know what the carbon dioxide level was when you were born, you can see how much it has changed in your lifetime. Now this is 20,000 years. No surprise I'm 51-ish. And what I'll do is put my CO2 birthday on this graph. So I'm a third of the way up that peak. So 2/3 has happened since I was born. It was around 318 parts per million when I was born, roughly in that region. So effectively, the changes are on our watch, and it's this speed of change which is the most compelling thing. It's important in this to factor the ocean in and what's happening to the ocean. It's very easy to get caught up with the headlines of what's happening on land. So we are creating a greenhouse effect, and a lot of energy is being created through that process. And the story you hear in the media is the fact that we're trying to limit the surface temperatures to a couple of degrees centigrade. And that's the climate energy on that bottom line. That orange is where that debate is. It kind of changes when you factor the ocean into it. So the newspapers right now, this weekend, as a result of the climate change report last week, were actually, some of the skeptical ones were saying, do you know what, there's a pause in the warming of the surface of the Earth, so it's not so bad as you think. The reason for that is because of what the ocean's been doing for us. That's actually what's been happening to the ocean. So the ocean since 1971 has absorbed around 93% of the extra energy in the system from the greenhouse effect. Now that does not mean that the ocean is suddenly going to become boiling hot. If you think of putting a kettle on, how much energy it takes to boil a kettle, it's a lot of energy. But we're putting that into the system, so the oceans are warming. In fact, the North Atlantic is one of the fastest warming areas around where you are. And the reality is that once you put the energy in, it's difficult to get out. So if we were to stop this now, and we were to cut that feed of energy and solve the climate problem, to mix the ocean to start to cool down would probably take 1,000 years. And so one of my end messages I'll trail now is that we're all in this together. Whatever your perspective is, we are altering things that are not going to be undone on a short timetable, and things are going to progressively change, and we need to work together to understand what they are and to understand the solutions. So the heating effect has been manifested in things which you'll have seen more frequently, such as the trend in Arctic sea ice. And this is the trend over the last 30 years. The line does go up and down. So for last year, it doesn't keep going down. It was the 6th worst in terms of the minimum extent. And this is another thing that as you look at these graphs, things are patchy. Some parts of the ocean are warming faster than others. And so it's a complicated picture. What we do know though, and this came through a couple of years ago, is that when you put all the polar models together, so one of the challenges was we had many teams working in polar areas. So when you put the models together, you got a clearer picture of what was happening. So we know by bringing together 20 polar research teams that we've added around 11 millimeters to global sea levels since 1992, and that's 20% coming from the polar ice sheets. Greenland's losing it around five times faster than 1992. And what's happened in terms of our predictions, and this has generally been a trend in a number of areas, is that it's actually happening faster than some of our predictions would have originally told us would be the effect. It's not just in the Arctic region. In the Antarctic region, we see a trend of abyssal warming, the deepest ocean warming through 24 ocean basins, down to 4,000 metres. This is perhaps not so strongly driven by some of the climate change I've been talking about, but perhaps some of the lesser understood consequences, including changes of wind direction around Antarctica, which is driving the water deep into the ocean. When we look at what's been happening to the ocean, we see a progressive warming trend. So the total depth warming is in purple, the upper 700 meters is in blue, and then the lower line is the 300 meters. So we are warming the oceans, not just at the surface, but across the spectrum. And this has consequences. Species are adapted to live in certain ecological niches. If you start to change some of those variables, species will move to try and get out of the bad conditions to warmer conditions. So you see, as it warms, species moving, vegetation moving up mountains as it if they like colder conditions. In the same way as in the ocean, we find that things will try and move, and some won't be successful. So there is generally an issue of a poleward shift to try and keep in habitable envelopes. But what we know from modelling is that a whole range of species are not going to be that successful at doing this in the ocean. So this is some work by a chap called William Chung, looking at 2050, and the intensity of the red shows areas where we expect the highest extinction levels to occur. And so you can see both around the equator, which is related to things like coral reefs, the water becoming too warm. So coral bleaching, which happens from time to time, will happen much more frequently and will, together with ocean acidification, cause the loss of species there. And the same in higher latitudes around where you are and in the Southern Ocean. When you look at species invasion, so species will be successful in moving, some of them. They won't go extinct, they will move. So you've already benefited here. It's not all bad news in a sense, because some commercially exploited species will come within Icelandic waters, but equally a whole range of species will invade particularly polar areas. The thing about all this is you can't pick and choose. What will happen will be determined by the overall shift of climate and chemistry conditions in the ocean. So you may find some good news stories in it, but there's a lot of bad news stories, as I'll show you in a short while about this. We see effects for some species that are highly sensitive to the amount of oxygen in the ocean. A warmer ocean not only contains less oxygen, but also can be increasingly stratified, reducing the amount of good quality habitat for species. So billfish, species like marlin, that are really important economically from a tourist perspective in the equator regions of the world's oceans. I've already seen a reduction of probably something like 15% of their habitat since 1960. It's predicted to go down to a 20%, rise to a 20% increase by 2020, and perhaps half the habitat in which they can flourish will be lost by 2050. This is a trend that is particular to equatorial areas. So, in fact, there's greater mixing in these parts of the world than is happening in some of the more tropical areas. So again, the picture is patchy, but some of the issues are potentially really serious economically. We also see a spread of dead zones across the world's oceans. And now these are connected to how we manage the interface of land and the ocean. So if we put a lot of material into the ocean that uses up the oxygen, particularly off estuarine areas, we see a growth in areas that have too little oxygen to support life. And we've seen a trend since 1960 of around 50 of these known areas expanding to some 500. The good news is we kind of know what causes this, and it's about poor understanding and management between what we do in the coastal zone and on land and in the inshore areas. And in that time, probably about 60 have actually been reversed. So there are things we can do if we put our mind to it on things that might seem to be impossible things to solve. We also see climatic changes affecting some species. Take the albatross, for example. They actually, for the moment, are probably doing a bit better. The wind speeds in their part of the world have picked up. Means they can forage more effectively, spend less time sitting on the water, and have more success in raising chicks. The question is, does that change continue if the winds get stronger? So there are winners and losers in this, but they will change over time. What we also know about the ocean is that we've tried to tackle some of the more obvious things, and we need to not take our attention off the issues. So when we look at pollutants, we've looked at things like anti-fouling and the effect that tributyl tin has on marine species, causing changes in the sexuality of species. We've looked at PCBs and things like that. The irony is that probably some of them are still there, and probably certainly for PCBs, probably more widespread in the ocean. We haven't necessarily solved some of those issues, but then we see chemicals of emerging concern coming along. So deodorants, Lynx, I shouldn't say brand names perhaps, Lynx or other deodorants have artificial musks in them. That's the smell you have, and people like particular brands. They're bioactive in the marine environment. We're introducing new classes of chemicals we don't know much about that are then acting alongside the ones previously we spent a lot of money on trying to solve. So the issue is we haven't necessarily got ourselves out of the concern envelope for some of these issues. But one thing that is really concerning people is the effect that the amount of carbon dioxide I showed you in that graph is having on the marine environment. If there's one issue out of the climate report that came out a couple of weeks ago where they are very confident that things are happening, it's on ocean acidification. So this is the fact that each year the ocean is absorbing and has been absorbing around 26% of the carbon dioxide that we give out through our activities. And it's been doing this, and in a sense it shields us, rather like it's absorbing the heat. It's been shielding us from the more immediate runaway effects of climate change and changes to the world we live in. The problem is when the ocean absorbs carbon dioxide, it forms carbonic acid in the surface layers that then dissociates. And it has two effects. One effect is that by the dissociation it drives the ocean towards more acidic conditions. And the second effect is that as a result of that, it decreases the availability of carbonates that are needed by marine species to build their shells and skeletons. And a lot of things that are essential to the functioning of the ocean that we might not use or we do use have skeletons made of calcium carbonate. Just think of all the shellfish, for example, you eat that are dependent on calcium carbonate. Think of the things in the ocean that absorb the carbon dioxide, the little coccolithophores, the little minute things in the plankton that form the white rain that take carbon dioxide out of circulation and ultimately trap it in deep sediments. They're dependent on this as well. So the reality is that the ocean by buffering the carbon dioxide is effectively using up its ability to do this and is changing. And what we now know is that we are doing this at a much faster rate than we could ever imagine. So in terms of changes to the ocean, we are changing it faster than perhaps in the last 33 million years, perhaps up to, in terms of scale, 170 million years. And this doesn't mean we haven't had changes in the past, but it means what we're doing is faster than has ever been done on the planet by our activities. So what I'm going to show you is an animation, and what will happen on this animation is the pH of the ocean will go down and the years will change, and we've used a positioning to show you Iceland in the context of the rest of the world's global oceans. Now this is a log scale, and we've already started changing the pH of the ocean. So since pre-industrial time, since that graph I showed you with 280 on it, and how far we've gone up that line, the ocean is now 30 times more acidic, or tending towards more acidic conditions than in pre-industrial times. By the end of the century, it's probably going to be 170 times more acidic, or tending to more acidic conditions. If the ocean on the warming would perhaps take 1,000 years to readjust, if we stop now, it probably will be 100,000 years to get it back down. Ultimately, the ocean will readjust, but it takes an awful long time to do it. So we're setting ourselves on a trajectory which is not a wise thing to do. I often say, even if the science on all this is half wrong, we shouldn't be walking down that pathway. So let me run this animation. So as this runs, you'll start to see in the polar sea, it'll start to change. And then this rapidly spreads out. So in terms of gross changes, the point is that there is still time. So you might have seen on that animation it didn't all change immediately. There are a few decades to work things out. But as I'll show you in a minute, some people are already suffering the consequences of acidification, as are some species. So how are species responding? Well, it was 10 years ago, around 2004, that ocean acidification really became a key issue. So this is a relatively young science, but a lot of countries have started to throw quite a lot of research money at this to understand what the consequences would be of minute changes in ocean chemistry to species. Now remember on the graph at the start, I showed it was 400 parts per million, and since I was born, it had gone up from around 318 to 400. On these graphs here, you can see control and 500 to 650. So that's not that far away. And what you're seeing in the kind of darkish red color is negative effects, no effects, and positive effects. And these are the some analysis of the experiments that have been done. So if you look at corals, basically as soon as we move higher, there's some pretty negative effects. There's one or two positive effects where species respond in a positive way. And the whole issue about this is whether these effects are linear or whether there are step changes, and we're still not totally clear on what thresholds look like for this. Negative effects are not just things may die. An organism building a skeleton has an energy budget, and it can decide to put more energy into building its shell, for example, and less into reproduction. So it may be able to sustain itself, but it may weaken its reproductive strategy. So negative things are about whether they get killed, whether they are unable to make their shells as well, perhaps they slow in growth, perhaps if they're organisms that photosynthesize, take energy from the sun, perhaps that's altered, or perhaps they become less abundant. So it's a complex cocktail, and this is perhaps one of the more concerning things, that it wouldn't be a good problem to have, but it would be an easier problem to manage if we knew there was a direct relationship. But you're dealing with real world and real species in this. So what do we know might happen? Well, we know that already organisms react differently. So it's not as simple to say some of these organisms that build their shells from calcium carbonate, or all of them, will equally be affected. That isn't the case. We know that corals and shell builders will decline, and we see that in the Earth's history. So we have had previous episodes of acidification in the past. We're doing it 10 to 100 times faster than anything in Earth's history. That's one of the problems, but we do know that things were knocked out in those events, and it took millions of years for them to come back. We know that some species will actually do better. So species like seagrass, they're a plant, high levels of carbon dioxide, photosynthesis, less things covering their fronds because they simply can't survive, they'll do better. We know that from some of the limited experiments that have been done that it can disorientate fish. So higher levels of acidity in ocean water can cause fish to either be unable to evade predators as well, or to become simply disorientated as part of their reproductive processes of juveniles finding good places where the adults live. Loss of prey affects predators. So we know that it's a connected ecosystem. So as I said earlier, you can't just pick a good news story in this and live with that good news story. It's going to affect all elements of ecosystems in some way or other. And therefore, looking at what that does to the things, some of the predators that perhaps we depend on for fisheries, will be really important to understand. We think that fish catches will potentially decline. And when we look to the future, how do we know some of this? Well, the fact is that there are some places in the world's ocean at normal seawater temperature that have a lot of carbon dioxide bubbling through them. So the Vesuvius in Italy. Near the Vesuvius is a small island, Ischia, and around that island, carbon dioxide bubbles through the seabed. And it actually does it more in one part than the other. So you can walk around the island and see the effects of increasing acidity of the seawater from the carbon dioxide bubbling up. And as you walk around the island, you can, if you want to, and I think the scientists don't recommend this now, you can actually get to a point where you can push your fingers through the limpet shells because the shells are so badly eroded. There's also a place, so that's for temperate waters in the Mediterranean. They found places in Papua New Guinea in the middle of coral reefs where carbon dioxide bubbles up. So again, we can get a picture of in the real world how species cope, and we're trying to put these fragments together. And what we know is that places where this happens are less biodiverse. Some species survive. So this is not a case of going to wipe the ocean out. There will be species which will survive, but it won't necessarily be the species that gives us all the ocean that gives us all the benefits. There'll be fewer calcifiers. As you reach higher levels of acidity in the oceans, fewer things are successful at calcifying. As I said, shells will be thinner. You'll have more invasive species because you're altering the ecosystem. You're preventing traditional things being in their place in ecosystems, so other things will invade and take their places. And seagrasses will flourish and you'll have less corals. So what does this mean for us? Well, it will affect us. 1 billion people are dependent on fisheries around the world, and coral reefs are incredibly valuable for a whole variety of reasons and purposes. So what I've shown you isn't a model for the future, it's affecting some people today. So on the west coast of America, there are a number of shellfish farms which produce the spat production for the west coast of America. $100 million industries, and they started to wonder why they were having 70 to 80% crash in success at breeding oysters that they'd done for years. And this happened year after year, and they suddenly realized it wasn't one farm, it was all the farms, and they tried to fathom out if there was some infection or some problem, and eventually NOAA came in and they measured the pH of the seawater. Now what's happening there is the fact that you get upwelling on the west side of continents by the way the earth and the oceans work. And the ocean water exists as a good layer, I call it a good layer with plenty of chemicals to build your shells, and then older, deeper water that is naturally more acidic. As the ocean's been absorbing a lot of carbon dioxide, it's actually weakening that buffer system, and so the horizon between the good water and the more acidic water has been rising by 1 meter to perhaps up to 3 to 5 meters a year in some places. And what they discovered on the west coast of America was it had risen sufficiently high that it could be swept into the productive areas on the shelf, and that's what they were sucking into the oyster tanks. They now have a coping strategy. They only pump on certain days, and part of the industry is trying to move to Hawaii to get out of that envelope. We now think that is a repeatable thing that could occur in South America with all the aquaculture, west coast of Africa, and other places. So this is something that is a consequence of acidification, but is real. They've managed to got a holding strategy to recover that industry. But what we also have now seen with new advances in science is that some of the things that are at the base of the food chain, and lots of things feed on little flying snails in the plankton called pteropods. They don't have a traditional foot of a snail, but they're like little wings, and they fly like little sort of bat-like things through the surface of the water. They have a shell, and what they've discovered in the upwelling waters around Antarctica is that the shells are dissolving. And this is one of these rare things where they saw it in nature, and then they went and did the experiments in the lab, and the lab experiments confirm what they've seen in nature. Whether that is progressive or whether it's always been there and we haven't looked for it yet, we don't quite know. But these are the sorts of changes that people are picking up as early warning. And so generally we think that it will affect aquaculture, fisheries and human livelihoods as it takes hold. So what's the future for the ocean? What do we want? Well, a lot of people have been trying to put their mind to that. And the world met back in 2012 in Rio de Janeiro. Around 45,000 people put their mind to it for this event. 188 countries, 100 heads of state. And they debated, what is the future that we want? And it was quite interesting because the actual marine community came together and said, it isn't the future we want, it's actually the ocean we need. And whether you're looking from an exploitation perspective, a conservation perspective, an enjoyment perspective, we actually are dependent on the ocean, and we value the ocean in all different ways. And we need the ocean to continue in ways that we find most profitable to ourselves from our different value point. So we face, I think, some choices which are becoming increasingly difficult because of these big stresses that we're putting on the ocean. We have depleted the ocean over time, we know that, and there's plenty of literature on that. We could continue and deplete it further. We could sustain it, or we could restore it. The big challenge and the big problem now is not just the regional scale issues that we struggle with, different perspectives, different points of view, but it's these multiple stresses that are going to act on all of us, on our values, and they will force us in the direction towards bad news. The question is, do we have the ambition to actually not just overcome some of our day-to-day challenges, but also have the ambition to actually try and do something about what we're doing to the general state of the ocean? So what is the ocean we need, and how do we get there? So I think this starts to come to some of the wrap-up of this presentation and some of the kind of core messages. And the first is that the situation is changing. It's changed. It shouldn't really be. We can all have differences of perspective, but it should no longer really be you or me or us and them. We are now all in this together. These changes are progressive. We don't know some of the thresholds. We know it's happening. There is high confidence that some of this is occurring. And we need to think of what can we do together, and how we can learn together, and how we can make better decisions together for the future, for the ocean. So I was invited to Australia a year ago. In Canberra, spoke to 100 political people. And I said to them, it's no longer about business as usual. It's going to have to be about business unusual, as I call it. New affiliations, new ways of working together, new ways of sharing knowledge to understand what we do. It is doable. We can change where we're going if we really want to. This book, if you haven't read it, I recommend you to read it. Solving apartheid in South Africa would be seen to be a tough problem. Solving ocean problems are a tough problem. Solving apartheid in South Africa didn't happen by accident. A chap called Adam Kane was part of a team that went in behind the scenes. He was a strategist from Shell, specifically tasked with solving difficult problems. They worked behind the scenes across the different parties to come up with a number of scenarios to head South Africa in a positive direction. They narrowed them down to 3, one of which was called lame duck. Another one was called flying flamingos. The birth of South Africa is actually the implementation of that scenario that they mapped out. And there's no mistake that Nelson Mandela has given comments on the book. So there are things that have been done behind the scenes to really alter trajectories, and we can do the same for the ocean. What would you do? Well, we definitely need to do something about carbon dioxide. Whether you are skeptical about glaciers melting or not, we can measure the oceans going more acidic. They're being measured in several parts of the world's oceans on long time series. They are heading in that direction. We can build and rebuild resilience in the oceans. We know that where you have more healthy ecosystems as part of an integrated management approach, when they get knocked down by one-off events or periodic events, it's those areas that recover earlier and seed other parts of the ocean. We can build the knowledge base, and I'm going to come back to this as a very final slide in just one moment. Knowing is then the ability to act. Understanding what all this means, whether in the UK or in Iceland, and sharing that knowledge base is fundamental to making good decisions. You may have different views on what those decisions should be, but you're working from the same information base. We need to protect more. We protect woefully little of the ocean. And if you think of those areas that are going to help us reseed other areas and support communities, 2.8% just doesn't do it. We need to provide effective governance for all the ocean. Do you know, in 2014, half the world's ocean doesn't have an effective decision-making process. Now, whether you agree or not with what the decisions should be within that half, which is the world's open ocean, the high seas, the fact of the matter is, unless you have a proper decision-making framework, you're not going to make good decisions. So we need to complete the framework for decision-making for the world's oceans. We need to remove perverse incentives that simply pay us to head in the wrong direction. We need to have greater sustainability and greater transparency in sharing. We need to involve more people. What I've been showing you should be all of us, shouldn't just be one or two people talking about it. And we need to engage people in a new way. So let me show how we've made this practical in the UK. So it was probably about 10 years ago, the UK government did a review and found alarmingly that they didn't have a handle on what was happening with climate change. And I was the guy given to solve the problem for them, for the oceans. And so I said, well, what if we get all our scientists together and we actually get them to share their information in an easily understandable form so that politicians could actually see what's happening across the board and then make their decisions however they want to make it. So we created something called annual report cards and special topics. And the special topic one we did quite recently was on fish, fisheries and aquaculture, where we looked at what all the science was saying and looked at the future of those industries. And we've also done it on the changes more generally. And we produce an annual report card. And in these annual report cards, we sum up across all the institutions in the UK what is happening now and how confident they are that that is happening on a standardized confidence scale, and get them to also say what they think will happen in the future and how confident they are. So over time, we can actually track whether we are more confident as a country or less confident in what areas, what do we think is going to happen, which provides a reasonable basis for then starting to make some decisions about where we go from here. We also launched an ocean acidification research program. So a number of institutes came together to fund this, so that we not only were doing experiments relevant to the UK to understand what some of these impacts were, but also we've established a number of transects where we know what the ocean chemistry is, so we've established baselines within the process more broadly for the UK as well. And that is really where I'll leave it. So as I say, it's a journey. It's hopefully giving you some new information about the ocean. And as I say, the key issue now is really understanding what those changes look like on a more regional scale, and working out how we can move forward together to actually come up with strategies that both cope with this, but also put in place rational decision-making frameworks so we can make good decisions in the face of these quite large changes that we now see affecting the ocean. Thank you very much indeed.